For our final video in this lesson, we're going to go into a topic that tends to give students trouble from time to time, and that's writing equations for parallel and perpendicular lines. Now, this tends to be a very popular question type for standardized test makers. They want to know that you can make that connection between parallel and perpendicular slopes and then put that value into a line. So in previous examples we've shown that you either are given the slope, you have to find the slope off a graph, or you have to calculate the slope yourself and then take that slope in a given point and plug it into the point slope form and come up with the equation. So this is going to be no different, except the type of information they're going to give you is they're going to give you a slope and then you're going to have to find the slope of either a perpendicular line or a parallel line before you plug it into the equation. And so you can see here in example 4 they give us two parts. We have an A part and a B part. And so they want us to find the equation of a line perpendicular and then the equation of a line parallel to y equals negative 3x plus 2. And so the first thing we have to immediately figure out is what is the slope that we're making comparisons to. And so we can see that this slope is m equals negative 3. And so in our first given equation we're doing perpendicular, and so we have to find the opposite reciprocal or the negative reciprocal slope, and then the given point of 3, 2. Now we also have to recognize that that given point is not a y-intercept or an x-intercept, and so then we would just simply use our point slope form as we've done in the previous examples, and you can see that our final equation is y equals 1/3 x plus 1. Now, in part B, they make it a little bit easier for us, and they simply ask us to find the equation of line parallel. And so since parallel lines have same slopes, we're just going to use the negative 3 again. And so in this case, you can see that we've simplified this down to slope-intercept form, and we're done. So sample problem 4 is going to have you work similar problems. Part A asks for a perpendicular line, and Part B asks for a parallel line. So go ahead and pause the video and take some time to do that now. Okay, and so we'll start by just identifying the slope, and so we can see here the slope of the line that we're dealing with is 2. And so if we want to find the slope of a perpendicular line, and I like to use that little perpendicular sign, we're going to use the opposite and then the reciprocal, which is 1/2. And so now when I go to write this, I notice that I have a 0 here. Now this time the 0 is actually in the y space, the y coordinate space, and so this is actually implying to us that this is an x-intercept. Now, if it were a y-intercept, this would be very convenient because we'd be able to just plug this into the slope-intercept form. But since this is an x-intercept, we're not able to do that. And so be careful not to fall for that little trick right there. So we're still going to approach this the same way we would with any other one. We're going to actually plug in values to our point-slope form, and so you can remember our point slope form looks like this. And so we're going to plug the point 2, 0 in. So that's y minus 0 equals our slope, which is negative 1/2, and then x minus 2. Now this is really kind of convenient because I don't have to do anything with the 0. I can just use y, and then I'm going to distribute the negative 1/2. So negative 1/2 times x, and then negative 1/2 times negative 2 is going to give me a positive 1. And that is our final equation in slope-intercept form. And so that line is going to be perpendicular to y equals 2x minus 1. And don't forget, if you really wanted to check to see that this worked out, you could actually graph both of these equations in your graphing calculator and just verify that they're perpendicular to each other. Our last particular question has us finding the slope, or excuse me, the equation of a line that is parallel to this line. So if the slope is equal to 2, then our second slope is also going to equal to 2. So I'm also going to use the point 20 for this particular equation. And so we're going to say y minus 0 equals 2 times x minus 2. And then I just have to simply simplify this. And that's a very straightforward, simple problem. Alright, so now you've had a little bit of experience writing equations of lines given perpendicular and parallel.